Please welcome our next speaker, Senior Director of Product Intelligence, Exiger, Griffin Fletcher, everyone.
Good morning, everyone. Griffin Fletcher, work on our product intelligence team here at Exiger, where we help some of the largest organizations understand their supply chain risk, extensively leveraging artificial intelligence to identify and build out bills of material, understand what's nested under the hood in both hardware and software supply chains. And today, if folks caught the session yesterday, we focused on supply chain diamonds, where the constrained points are inside of a supply chain pyramid that really drive and elevate that risk. Today we'll walk through and actually demo some of that technology that enables us to do this at scale. So we'll start by really addressing and framing the problem. Inside of supply chains, whether this is a Ford F-150, an F-35, a piece of software, the latest iOS update, or indeed Exiger's One Exiger AI software, that is made outside of the four walls of any one organization. We know that we have dependencies, particularly in critical minerals, on China, down to the hole in the ground. At Exiger, we focus not only on where particular components are manufactured, but who is manufacturing them. We may know that we have gallium and germanium inside of the supply chain for an F-35, and we may think that we have an allied source in Germany as a gallium refinery, but ultimately that gallium refinery is fully owned by the CCP. So Exiger's view is really understanding where particular components are manufactured and who is materially transforming them. It's an increasingly complex problem. When antimony restrictions are announced out of China back in September of 24, procurement professionals point the finger over to engineering to say, where is antimony across all of our systems? Engineering points the finger right back to procurement. No one clearly owns the problem. And increasing disruptions, Strait of Hormuz disruptions, strikes against a helium processing plant extend across multiple product categories. So it's important to understand the particular products themselves and understand them through the lens of criticality and viability, which we'll walk through here in the platform. Again, a hallmark of what we talked about yesterday, folks often approach supply chain mapping as I want to have every product mapped down to the hole in the ground. Really, the focus of supply chain mapping is a means to an end. We're trying to understand where we have these concentration points. Where do we know that there's only 3 suppliers of magnesium castings domestically here in the United States? The drones that are flying behind us, we don't have to map those all the way down to the hole in the ground to know that we have constraints on lithium hexafluorophosphate, of which we have no domestic suppliers here in the United States. To map out these supply chains, to understand where that pyramid really constrains down into those choke points of the diamond, we leverage over 30 million unstructured data sources, 16,000 structured data sources, and a large corpus, the largest supply chain knowledge asset of over 400 million part attributes. That's really done through extracting off of technical data packages to understand what's inside of particular part catalogs. We'll look through traditional sources, shipping data, bills of lading, financial reports. Did TSMC announce that they're so excited to build a new fab that produces at 20 nanometers that is constraining that supply chain and forcing those into that particular fab? Much in the same way that we leverage NLP to process and understand the risks of a particular company, we leverage that same technology to understand supplier relationships. Did somebody announce that they're so excited to be supporting a particular program or partnering with another supplier? And really key to our understanding is parts catalogs. Exiger's technology is leveraged by both the Defense Logistics Agency and General Services Administration as all new products are loaded onto those catalogs. So as a DLA cataloger in Battle Creek, Michigan is loading a new F-22 part, they're running that technical data through Exiger first to understand, have we seen this part before? Maybe it's a different part description, part number, or supplier name, but it's a form, fit, function alternate for a part that's already been cataloged. Now those parts inside of those catalogs, references across different proprietary and mil specs. ASTM B271 nested in one of those parts, we're extracting to know this is a copper centrifugal sand casting that contains 2% antimony and is ultimately receiving a cadmium surface treatment, which enables us, when we start to map supply chains, to really meet our customers where their data resides. In some cases, folks have millions of technical data packages, PDFs, engineering documents that are informing what the procurement teams are responsible for sourcing. We'll integrate with product lifecycle management tools to bring that engineering data to inform the supply chains that we're building out, and preferably bi-directionally with those PLM systems. So as engineers are designing new components, they're designing it with the supply chain in mind. We know when we design a samarium cobalt magnet motor that ultimately is going to rely on China. So the extent that we can bring together those procurement and engineering different viewpoints, we prefer to integrate bi-directionally. But in many cases, as we see here on the left with the exclamation point here on the slide, a lot of black box items. All that we know is the product's description, a part number, the supplier name. Somewhere in the middle, NSNs, NINs, different part catalogs, different capabilities that we leverage to map out those supply chains based on that available seed data. So really core to the approach to both supply chain mapping, going beyond just mapping for mapping's sake, is understanding what parts are most critical and least viable inside of my supply chain. I can't function without these three parts. They're leveraging castings and forgings. We don't own the technical data, and the supplier just burned down for those three parts. Bringing together that view enables us to not map the entire universe just for mapping's sake, and really focus on where those critical disruptions are impacting those most critical parts. Increasingly, I think a lot of the discussion here on the floor has focused on critical minerals and the outsized advantage that China has developed in processing of rare earth magnets in gallium and germanium. Restrictions on antimony announced in September of 24. Those restrictions, when DLA looks across their FLIS data, DLA sees about 500 parts that contain antimony. When we look across that same data set, we see over 11,000. That's really because DLA is looking just at the part description level. Does this contain antimony? And not unpacking those nested specs and standards to really understand that 2% inside of that copper alloy used in that sand casting. New restrictions just earlier this week on sulfuric acid. In many cases, these restrictions are adversarial in nature to cripple what they know about our defense industrial base. Some of them sulfuric acid, right ahead of planting season, they need that sulfuric acid to make the fertilizer that they need to feed their people. We'll show a few more examples here. Whether we're ingesting a technical data package, in this case received 85 PDF drawings for a wiring harness on the Bradley fighting vehicle. This particular data package was for a wiring harness. This wiring harness had long lead times, continuing to increase. The customer ultimately didn't know why those lead times were increasing. We analyzed those 85 PDF drawings, understood that there were 3 copper castings on that wiring harness, where it connected back to the Bradley itself. One of those copper castings was obsolete, and that information never left the casting house, back up to the wiring harness manufacturer, back up to the Bradley manufacturer, and ultimately back up to the US Army. They weren't aware that there was increased demand and tempo as they were being fielded in Ukraine. So able to understand inside of that engineering data what's ultimately a supply chain risk and a sourcing risk, and go beyond just the identification of here is the cause of that delay to who else has produced cadmium centrifugal sand castings over the past 20 years, and how many parts have they provided to the US government. So we can start to identify potential alternates based on that procurement history with that granular detail of exactly what those particular parts are. I'll switch over here for a moment, hope the screen carries with me, and we'll walk into one Exiger AI. Exiger, over the past 6 months, has invested heavily in building out an AI product development lifecycle. That enables us to have a conversation here today on the floor on a Friday, and by Tuesday afternoon, we're shipping a new feature, we're changing a widget, we've built a new workflow in a way that enables us to scale much faster. We'll walk through a few of those different workflows. Core, as we noted, we can map off of the technical data package, but in many cases, all that folks have is a product name, a product description, and a supplier name, and they're looking to better understand, do I need to worry about this, and what's inside of that supply chain? So inside of the platform, we can look across the different companies, products, and parts that are nested in that supply chain. We can input, whether again that is the technical data, whether that is a bill of materials, whether that is a part number, load in that particular product, and generate exactly what the subcomponents are that are necessary to manufacture this product. In this case, a complex boot. This boot, we're assembling and identifying the necessary subsystems to produce this particular product. Can go down as low as the materials down to the hole in the ground for that particular system. We'll generate out what's necessary to produce this particular boot. And as we identify what those necessary subcomponents, subassemblies, and materials are, we'll start to identify what the actual manufacturers are that are capable of producing these items. So again, where we have the technical data, where we have an ERP system, a PLM, important to integrate those, but in many cases, all that we have is, again, that black box item. So as we research the supply chain, leveraging a RAG model to identify courses of action, we'll build out what those necessary suppliers are for the upper construction, the upper material there inside of that boot, and we'll start to identify each of those suppliers that are necessary there inside of that process. After we've identified, here is that T8 Extreme Evo GTX boot, here are the necessary components to construct this particular boot, and then here are the potential suppliers that have manufactured similar components necessary based on the specifications of the boot that we've extracted. In the same way as we're building out bills of material, we're responding to increasing disruptions around the globe. As we've built out our supply chains, our third parties, the entities that we do business with, we're increasingly leveraging command centers, bringing together both humans and AI agents to process the different actions that supply chain professionals are doing every day, being asked to do a lot more with a lot less to build out those supply chains. So here we can see a list of our different AI teammates, the number of processes that they've completed, as well as the acceptance criteria for those. As they move closer to 99.99%, we're able to turn on that auto accept function to go qualify that alternate source of supply, to perform the business functions that are necessary for supply chain disruptions. So we have our human team members alongside our agentic team members. We have a disruption that's coming across our desk, in this case, forced labor allegations against Lens Technology, a specialty lens and glass manufacturer. It's identified through open source reporting that Lens Technologies is leveraging Uyghur forced labor, and it's then launching this particular command center after we've identified this alert. So we're either watching, investigating, or in the case here, the AI is recommending that we launch a command center to identify our exposure at the product level for this particular product. We can go to investigate impact. All of the supply chain has already been mapped. We've mapped out each of those components, and we're now launching those different workflows to identify the products and suppliers that are connected to that alert through Lens Technology. We can see the risk of each of the entities in that supply chain, their foreign ownership, their environmental social governance, their cyber risk. We're now launching that command center to bring together both our AI and human teammates to go to solve this particular vulnerability. So at first, it's identifying the first action that we need to take, whether that's a human in the loop or AI agents, to scope and identify whether this aligns with our risk framework inside of our organization. And as we view this workforce, we're identifying each of the steps that are necessary after the risk has come in, identified the necessary steps to mitigate it, and then where the humans and agents work together to ultimately mitigate after that trigger event has started out this particular workflow. It's also identifying conditional decisions. Where do we need that human in the loop, and where does it fork into different paths after we've identified it? Fully configurable, again, based on an organization's risk tolerance, the individuals that they have on their team, what technology they're using today. But as we open particular tasks, we're being asked here to upload an evidence pack to identify whether or not this entity is ultimately reliant on this Uyghur forced labor. So we're uploading that particular document, it's analyzing that document, and as it moves throughout the process, we're working through individual steps to ultimately get us closer to the final decision. Do we continue this business relationship, or do we work to offboard this particular company after the research has been conducted? In the case, it's recommending that we offboard the company. We've selected offboard the company, and now as we've worked with the organization to understand their workflows, we're now launching that offboarding process, and it's flowing through the different systems that we operate in to offboard that company, get them off the books, and ultimately identify alternate suppliers for that particular component. I see here that we're running up against time. We have about 30 seconds, had one more to walk through. But if folks are interested, we're right there outside as we exit booth 800. I think we have about 30 seconds if anybody has one lingering question. Happy to answer those here, or we'll address those there at the booth. Please.
We can't hear you, I don't think.
A little difficult.
We are right up to the minute. You may have to speak to him afterwards.
great.
If it's a very quick question.
Oh, it was just a quick question on advanced manufacturing, if you're also identifying when they can insert advanced manufacturing.
Yes, we are. Increasingly, particularly in the DOW, a lot of those cases, where can we manufacture these organically within Army depots, looking at that additive manufacturing acceptance and readiness, and then actually, in many cases, working with partners to additively manufacture those.
Thank you so much, Griffin. If you would like to speak to him any further, he will be at booth 800. Is that correct?
That's correct.
Thank you. Thank you, Griffin.